Hello viewers, I'm Kausalya. Today we are going to solve problems related with maximum power transfer theorem. So here the problem is determine the maximum power delivered to the load in the circuit shown. So here this is our given circuit diagram, and in this circuit diagram you see here we are having a current source, right? That is an alternating current source, and here this is our load impedance. So we have to find the maximum power that is delivered to this load, right? So the first thing is here we are having two terminals A and B, right? So since this load impedance is connected across these terminals, right? So the voltage across this AB, it is nothing but voltage is nothing but it is the product of current and impedance, right? So the current flowing through this part multiplied by the respective impedance 3 plus J4. So this forms your voltage across AB, right? Now we are going to calculate the current that flows through this 3 plus J4. So here in this case again you see this is our current source, right? And this current source when reaching this node it gets divided into 2, and again this entire current flows through this part because these two are connected in series. So whenever we are calculating the current or voltage, okay, we should omit this ZL, right? We should assume that the circuit ends by this, right? So here in this case, this is your total current, right? And this total current splits at this node into 2. Therefore, here the formula is by, again, current division formula, right? The total current into opposite resistance. So here we are expected to calculate the current that flows through this path. Okay, here the same current that flows through this area flows through this, okay, since these two are connected in series. So therefore by current division rule, total current into opposite resistance. So here the resistance which is opposite to this part is this one. So minus J10 divided by total resistance. Here you have to include all these values, right? This is what I had written here. Total current into opposite resistance. Here the opposite resistance is minus J10 divided by total resistance. It covers all the things here. Okay, minus J10, 5, minus 6J, 3 and 4J, right? So just write all the things here. And once you solve, finally we are ending up with the answer like this, right? So this is the value of current that flows through 3 plus J4, right? Now the next thing is we are going to calculate the voltage. So voltage is nothing but I into R. So this is your I and this is your R. Here it is Z, right? So just multiply and here the answer is 173.35 with an angle of 19.43 degree volt, right? So the next step is we are going to calculate our Z Thevenin, right? So this is our V Thevenin and the next step is Z Thevenin. So how to calculate Z Thevenin here? So in this case, we have to look back, right? So this is your circuit, okay? We have to remove this ZL and here you have to look back. So when you look back, what happens? You see current flowing from this path, okay, it gets splitted up into 2 here. Right. Again, this current when flows over this part, okay, at this node, it gets again divided into 2. Can you understand? Now we are going to calculate Z Thevenin. So we have to proceed from this end. So in order to know the connection of series and parallel, we are assuming that a current flows in this path, how it will get divided, right? When the current gets divided, then those two elements are parallelly connected, right? So here you see when you look at this node, these two things are parallelly connected, right? So what is the formula for parallel connection? Z1 into Z2 divided by Z1 plus Z2. So here in this case, just substitute the values here, right? So Z1 into Z2 divided by Z1 plus Z2. So here the answer is 8 minus J 14, right? So this combination comes in Now we have reduced these two into a single thing. Okay, that combination comes in series with this part, right? So for series combination, you have to simply add. So here when you add, the final answer is this, right? And that combination, wait, let me show you, right? And that combination, you see, comes in parallel with this, right? These two combination of resistors comes in series with this part, right? And hence this combination is in parallel with this part. Therefore, here we are ending up with a final value of Z Thevenin as this one, right? 4 plus J 3.5 ohms here. Now we have calculated V Thevenin and Z Thevenin, right? So as per the thing, to get the maximum power, the load impedance must be equal to the complex conjugate of the source impedance, right? So here what is the value of Z Thevenin? It is 4 plus J 3.5 in order to have maximum power transfer. So the value of this ZL should be complex conjugate of this one. So here it should be 4 minus J 3.5 ohms, right? So once you draw the circuit, here this is our circuit, right? VAB or V Thevenin, and here this is your ZAB and this is your ZL. So in order to calculate the current that flows through this path, the value of current is given by, it is V by Z here, right? Therefore, the value of V Thevenin, it is nothing but, right? This is the value. Okay? This is the magnitude, or this is the value of your V Thevenin. Therefore, here this is your value of V, right? And Z Thevenin, here we are having two parts, right? ZAB and ZL. So here in this case, the value of ZAB is this one and ZL is this. So when you add these two, imaginary terms cancel each other, and here the final thing will be, we will be having 8. Right. So here the answer is 21.66 amps here. So maximum power is given by the formula I square R. Here we are having the value of I. Right. And what is the value of R in ZL? The value of R is the real term, that is 4. So just substitute it here, and the final answer is 1874.9 watts. Right. So this problem gets over here. We will proceed with the next one. For the circuit shown in figure, find the value of Z that will receive maximum power. Also determine this power. Right. So here in this case, again the same thing. We need to find the value of Z and also the maximum power. So here we are proceeding with the first step as finding the value of Z Thevenin. That is the Thevenin across the terminal AB. Right. So therefore here, when you look at this circuit, you see at this node, the current gets divided into two, right? So these two combination are in parallel. Similarly, these two combination is also parallel, right? So here we are writing the value of ZAB as 5 into J10 divided by 5 plus J10, and again 7 into minus J20 divided by 7 minus J20. Right, these combination comes in series. Therefore, here we are having a plus. So once you solve, the value of Z is calculated as this much. Right. Now again, the value of Z should be the complex conjugate. Right. So therefore, the value of here, the complex conjugate is 10.236 plus J.182. Right. So here we have calculated the value of Z, that is load impedance. Now the next thing is we are going to calculate the value of V Thevenin or voltage across AB. So here just we are redrawing the circuit. So while redrawing the circuit, the thing is we have to remove the load impedance. Okay, this load impedance have to be removed. Right, the rest they will remain the same. So here in this case, you see again, right? Now observe carefully. We are having the terminal A, right? So just look at this. To this terminal A, we are having 5 ohm and J10 ohm, and they are parallelly connected, right? So here again the same case. You see here this is our terminal A, and to this terminal A 5 ohm and J10 ohm are parallelly connected, because at this node here the current will divide, right? Similarly, to this B, we will be having the 7 ohm and minus J20, and they will be again parallelly connected, right? And to this combination, you see the voltage, right? So the voltage terminal one end is connected to 5 and 7 here. So similarly, you see one end of this 5 ohm and 7 ohm are connected to this voltage, and the other end are connected to J10 and minus J20, right? Here simply the above circuit diagram is redrawn. Now we are going to calculate the current. Let I1 is the current that flows through this, and I2 is the current that flows through this path. So I1 is nothing but V divided by impedance, right? Because this 100 volt is impressed across this path as well as for this path, because here all these three are parallelly connected. Therefore, I1 is 100 by 5 plus J10, and I2 is 100 by 7 minus J20. Once you solve, here we are getting the answer like this. Right. The next thing is we are going to calculate the voltage across AB. So here again you can consider this path to calculate or this path to calculate. Both will give you the same answer. Right. So here in this case you see the current flowing through this and this is, they are opposite to each other. Right. When you look at this as a closed path, you see here current comes like this and here current comes in opposite way. Therefore, VAB is given by 5I1 minus 7I2. Right. It's up to you. Even you can take minus 5I1 or plus 7I2. Right. So here, finally, we are ending up with the answer like this. Right. Again, we are going to draw this Thevenin's equivalent circuit. So this is your Thevenin's equivalent circuit. So here let I is the current that flows through this circuit. Therefore, the value of I is given by V Thevenin divided by Z Thevenin plus ZL. Right. So V Thevenin we have calculated, and Z Thevenin we know, and ZL it is complex conjugate of Z Thevenin. That's it. So just substitute the values, and here we are ending up with the answer as this is your value of current. Right. So the current when represented in polar form, we are having this expression. Now the next thing is we have to calculate the maximum power delivered to the load. So that is given by I square R. Right. So here the value of I is this one, and the value of R. So here the value of R is taken from the ZL. So in ZL, what is the value of R? It is nothing but, you see, this is the value of R, that is 10.236. So just substitute the values here, and the final answer is 125.749 watts. Right. Here comes the end of this problem. If you have any doubt, let me know in the comment section. Thank you.